expressions without an equal sign. Okay, it's not an equation, there's no equal sign. And it contains at least one variable and one operation. So here you've got our variable, got subtraction. We've got variables, we've got addition and multiplication there. Here it doesn't look like there's an operation, but when you got a number next to a letter, that is multiplication. So that technically is an algebraic expression. So let's look at writing expressions. First off, there's two things we do when we write expressions. We define the variable, and then we actually write out the expression. So here, we're looking at what is the unknown. Well, we don't know what the number is, so n equals a number. I'm going to underline my unknown, okay? Then, we're looking at writing our expression. So, we have our number 7 and our unknown number, and then knowing that quotient means division. So we're dividing a number and 7. So the best, most algebraic way to write that is using the fraction bar. Do not use the division sign. Okay, we want to get away from that when we're getting into algebra. Number 2, 5 times the sum of a number and 7. So again, defining our variable, the unknown. We don't know what the number is, so I'm going to say n equals a number. Now I'm looking at what values are given to me. I have 5, I have 7. For operations, I see times and I see sum. So it's 5 times what? It's 5 times the entire sum of a number and 7. So it's 5 times a sum. I'm going to put that in parentheses. Well, what sum are we looking at? We're looking at the sum of a number and 7. And last one, John is 3 years younger than twice Sarah's age. Okay, so what is our unknown here? We don't know how old Sarah is. So I'm going to use A for age because S would look like a 5. So A equals Sarah's age. Okay, let's look at the numbers that are given to us. 3, twice, which means 2, but twice also means multiplication, and younger than means subtraction. So remember, with subtraction, the order is important. So 3 years younger than. That means we are subtracting it from something. What are we subtracting it from? Well, it's 3 years younger than twice Sarah's age. So 3 years younger, taking that away from twice Sarah's age. Let's look at evaluating expressions. Okay, this is where you got to be really, really careful with your use of integers, making sure you're paying close attention to negatives, because one missing negative can throw off the whole entire answer. So the word evaluate means just to find the value of. You're not solving because it's not an equation, so we call it evaluating when we're just finding the numerical value, or simplifying when we've got algebraic expressions in it. So we're going to plug in if x is negative 9 and y equals negative 3. So in here, I'm keeping in my negatives and my subtractions, and then I'm plugging these in. I'm going to do it in parentheses so I don't make a mistake. So the opposite of y, well, y is negative 3, minus x squared. Well, we're doing negative 9 squared. Okay. So we got to simplify this, right? So minus a negative, or the opposite of negative 3 is actually positive 3, minus, I need to do these exponents first before I do this subtraction. So negative 9 squared is actually 81, positive 81, okay? Now we can subtract 3 minus 81. Well, think about your integer rules, okay? You can keep the first number, change it from subtraction to addition, change it from positive to negative, or you could look at it as a grouping and say, I have positive 3 and I have negative 83. So I have opposites. I'm going to find the difference. 81 minus 3 is 78, but I have more negatives than I do positives, so it's negative 78. All right, number 2. We're doing the opposite of x, the opposite of negative 9, minus the opposite of y, which is negative 3. Okay? So the opposite of negative 9 is positive 9, minus the opposite of negative 3, which is positive 3. So we're just doing 9 minus 3, which is 6. 2 more evaluating problems, because this can be a little tricky. It's really about paying close attention to the negatives and the positives. So we're going to plug in the values here. Z is negative 10 minus our x value of negative 12 plus our y value of 4. So I'm going to do my parentheses first. Negative 12 plus 4, we're adding opposites, so we find the difference, which is 8. There are more negatives than there are positives, so it's negative 8. So we bring everything else down. Negative 10 minus negative 8. Well, when we are subtracting a negative, keep the first number. Change it from subtraction to addition. Change it from negative to positive. So we really have negative 10 plus 8. So we are adding opposites. So we find the difference, which is 2. But we have more negatives than positives. So it's a negative result. All right, number 4. We have negative x squared over y. So I want to be careful with this one, and I want you to think logically about this, because this is where we see a lot of people make mistakes. Even though there's no number right there, that technically is negative 1x squared over y. The reason that I want to write it like that is I want you to think, when you've got a number right next to a variable, the operation that is multiplication. Okay, so we've got multiplication, we've got exponents, and we've got division. So if we think logically here, what comes first for our order of operations, right? Please excuse my dear Aunt Sally. We have to do exponents before we multiply or divide or add or subtract. So I need to square the x value first. So this really is negative 1 times negative 12 squared over our y value of 4. So I'm going to square negative 12 first, which is positive 144. But then we're multiplying that by negative 1 before I divide. So negative 1 times positive 144 is negative 144 divided by positive 4 is, let's calculate that. I didn't do that one ahead of time. 144 divided by 4 is 36. So negative 36, because it's a negative divided by a positive. Okay? That was evaluating. You got to be really careful, because it's really important to be paying attention to those positives and negatives. It can really throw you off. Okay? So now the last thing I want to look at is greatest common factor. So the greatest common factor of the greatest number that is a factor of 2 or more numbers. So it could be of 3 numbers, 4 numbers, however many you want. So for example, the GCF of 24 and 18. The biggest number that multiplies into both of them is 6. Okay? You might be able to do that stuff in your head. If not, I'm going to show you how to do it with prime factorization. Okay? So what we're looking at here is we're looking at monomials, algebraic expressions. So not only do we have to find the GCF of the whole numbers, but we also need to find the GCF of the variables. So one thing I want to look at is, you might be able to look at 16 and 24 and know what their GCF is right away. But if you don't, you can do prime factorization. Okay, so that's when you're breaking it up. Pick 2 numbers that multiply to 16. So if I pick 4 and 4, are either of those prime? No. So I'm going to pick 2 more, I'm going to split each of those up. So 4 splits into 2 and 2, 4 splits into 2 and 2. Now these are all prime numbers. So our prime factorization of 16 is 2 times 2 times 2 times 2. For 24, pick 2 numbers that multiply to 24, 4 and 6. Neither one of these is prime, so I'm going to keep going. Split 4 into 2 and 2, split 6 into 2 and 3. Now those are all prime. That is our prime factorization. So I'm going to list out over here. We've got, for 16, x squared, 2 times 2 times 2 times 2. Okay? Then We also have to think about the x's. It's x squared, which means there are 2 x's being multiplied here. Now for 24, x to the 4th. We have its prime factorization, 2 times 2 times 2 times 3. Then we have to look at the variables. There's 4 x's. So it's x being multiplied 4 times. Now we have to look at what they share. They share a 2. They share another 2. They share another 2. No other numbers, but they share an x and another x. Okay? So we're going to multiply. 2 times 2 times 2 is 8. And they share 2 x's, so x squared. 8x squared is the GCF. All right, let's look at number 2 for this one. 18 and 42, again, you might be able to look at it right away and know what the GCF is, but if not, let's do that prime factorization. So 18, I'm going to split into 2 and 9. 2 is prime. 9, I'm going to split into 3 and 3. 42, I'm going to split that in 2 and 21. 2 is prime. 21 splits into 3 and 7. Now that I have my prime factorization, I'm going to list out those factors. So for 18, x cubed y squared, it is 2 times 3 times 3. But then we got to factor in both variables. We have x to the 3rd, so 3 x's. And we have y to the 2nd, so 2 y's. For 42, x y squared. We had prime factorization, 2 times 3 times 7. Then we have 1x, and we have 2 y's. So let's look at what they share. They share a 2, they share a 3, they share 1x, and they share 2 y's. So the the GCF is 2 times 3, which is 6, with 1x and 2 y's, so y squared. Let's look at one more. This time we're looking at 3 numbers here. So 84, 24, and 10. If you know the greatest common factor right away, great. If not, let's do that prime factorization. 84 can split into 2 and 42. 42 splits into 2 and 21. 21 splits into 3 and 7. 24, I'm going to split that into 2 and 12. 12 into 2 and 6. 6 into 2 and 3. 10 splits into 2 and 5. So let's write out our prime factorization here. So 84, a to the 5th, b to the 2nd, c. The prime factorization is 2 times 2 times 3 times 7. There are 5 a's times a times a times a times a times a. 2 b's times b, and 1 c. For 24, a, b squared, c cubed, we have 2 times 2 times 2 times 3. We have 1a, 2 b's, 3 c's. And the last one, 10, a to the 4th, b to the 3rd, c. Prime factorization is 2 times 5. We have 4 a's, 3 b's, and 1 c. So let's look at what they share, that all 3 of them share. They share a 2. And then the 10 only has a 5. Nowhere else is there a 5, so the only number that they share is 2. Now let's look at their variables. They each have an a. 24 only has 1, though, so they don't share any of the other a's. They each have a b. They each have another b. But that's it for the top 2, so that's all. They share 2 b's. And then they each have 1 c, but that's it because the top one doesn't have any more. So their prime factorization, or their GCF is 2, 1a, 1b, 1c. So, nope, I lied. 2 b's, so 2ab squared c. Okay?